Good morning, students. I welcome you all to my online class on dynamics. So in last class, we have solved 3 problems on simple harmonic motion. So today we'll solve 3 more problems based on simple harmonic motion. See the next problem, number 4. In a simple harmonic motion of amplitude A and periodic time t, prove that integral 0 to t v square dt is equal to twice pi square a square by t. So here what is given? In simple harmonic motion, amplitude is given a and periodic time is given t. So with the help of that, you have to show it is integral 0 to t v square, v is the velocity, is equal to twice pi square a square by t. Here a is the amplitude and t is the periodic time. Okay, so how to get this result? So first you see, for a simple harmonic motion we have, so what is the expression for x? You can say the displacement, it is a cos root over mu t. So this you write as equation 1. So from this we can find out the expression for v. V is given by, if you differentiate x, you will get the velocity, rate of change of displacement. It is given by minus a root over mu sine root over mu t. This you write as equation 2. And you know the expression for time period also. So what is the expression for time period? So we can write, so just to see the expression for time period. So what is the expression for time period? It is twice pi by root over mu. So from this root over mu will get twice pi by t. Okay, now let's take the left hand side. What you have to prove? You see integral 0 to t v square dt, that is the left hand side, and right hand side we have 2 pi square a square by t. So we have taken the left hand side. In left hand side we have integral 0 to t v square dt. Okay, now see here t is equal to twice pi by t. So in this, if you see the limit of integration, here the limit is 0 to t. So this t we can change by what? Twice pi by t. And we know the expression for v. So for v square is equal to what you will get? Just now we have written the expression for v. It is a square mu sine square root over mu t dt. Okay, now in order to evaluate this integral, we will take the help of method of substitution. So substitute root over mu t is equal to z. So from this root over mu dt you will get dz. Okay, now change the limits. When t is equal to 0, z is equal to 0. When t 0, see when t 0, z 0. When t is equal to twice pi by root over mu, z is equal to twice pi. So do this substitution in this integral. So what you will get? Now the limit of integration, you will get 0 to twice pi a square mu sine square. In place of root over mu t you will get z, and in place of dt what you will get? It is dz by root over mu. So take the constant thing outside, a square root over mu. So you will get integral 0 to twice pi sine square z dz. So if you take the help of properties of definite integral, I think you know one result. Integral 0 to twice a fx dx, we can write it is 2 times of integral 0 to a fx dx if this function is an even function. So if we apply this result, so what will get? We can write 2 will come here, so it is integral 0 to pi sine square z dz. So again we can apply the same results, then here it will be pi by 2 and one more 2 will come here. So if you apply that property, so ultimately you will get 4a square root over mu 0 to pi by 2 sine square z dz. So for this we can apply the reduction formula. So this is I2, n is even. So what is the reduction formula for this? 1 by n, so it will be 1 by 2, then it is pi by 2. So if you simplify this expression, so what you will get? It is a square root over mu pi. So it is pi a square root over mu. You see the expression for root over mu, it is twice pi by t. So if you substitute the expression for root over mu and simplify, you will get 2 pi square a square by t. So that way from left hand side you will get the right hand side. Okay, let's solve for the next problem, number 5. Just to see the next problem. In a simple harmonic motion, the distance of a particle from the middle point of its path at 3 consecutive seconds are described to be x, y, and z. Show that the time of a complete oscillation is given by twice pi by cos inverse x plus z by twice y. So here, see here what is given. Here the motion is simple harmonic and the distance of a particle from the middle point means from the center or the mean point are given as x, y, and z. So with the help of this we have to show that the time of a complete oscillation, that means t is equal to what? Twice pi by cos inverse x plus z by twice y. So how to proceed? So we can consider this way. let d be the distance of the particle from the center, middle point from the center at time t. Then we know the expression for the displacement. D is equal to what? X is equal to what? A cos root over mu t. So in place of x we can write d is equal to what? A cos root over mu t. Now suppose according to the condition C, d is equal to x when at 3 consecutive times. So when d is equal to x, t is equal to what? We can consider t is equal to t naught. When d is equal to y, when the distance is y, then time will be t naught plus 1. When d is equal to z, then we can consider t is equal to t naught plus 2, because it is given distance x, y and z at 3 consecutive seconds. So that way we can take the condition. Now use this condition in equation 1. So use the first condition, what will get? X is equal to a cos root over mu t naught. If we take the first condition, second condition, y is equal to what? A cos root over mu t naught plus 1, and similarly z will get a cos root over mu t naught plus 2. Okay, now see, if you see what you have to prove, see here, it is cos inverse twice pi by it is twice pi by cos inverse x plus z. So just to find out the expression for x plus z. So how to get the expression for x plus z? You just add equation 2 and 4. So there's some mistake. So here we are adding equation 2 and 4, not 1 and 3. So if you add equation 2 and 4, so what will get? X plus z. So right hand side also you add 2 and 4. A I have taken common, cos root over mu t naught plus cos root over mu t naught plus 2. So here you have to apply the formula for cos c plus cos d. So I think you know the trigonometric formula for cos c plus cos d. Twice cos c plus d by 2, then cos c minus d by 2. So when you simplify this one, here say t naught plus t naught, you will get twice t naught plus 2. So ultimately you will get t naught plus 1. When you simplify this one, you will get here minus 1, because t naught cancel. So here you will get minus 2 by 2 minus 1, and cos of minus theta is cos theta. So this value will be positive only. So you are getting twice a cos root over mu t naught plus 1, then cos root over mu. So this part, if you see nicely, this is the expression for y, a cos root over mu t naught plus 1. So what you will get? X plus z is equal to what? It is twice y cos root over mu. So by equation 3. So from this, what is the expression for cos root over mu? It is x plus z by 2y. So find out the expression for root over mu. It is cos inverse x plus z by twice y. So from this, you can write down the expression for t, time period. It is twice pi by root over mu. So if you substitute the expression for root over mu, you will get twice pi by cos inverse x plus z by it is twice y. So this way you can prove the value. So let's solve one more problem. See the last problems. It's very simple, almost similar type. One similar problem already we have done. See the next problem. A particle executing simple harmonic motion in a straight line has velocities v1, v2 and v3 respectively at distances x1, x2 and x3 from the center of the path. So almost similar to the previous problem. Prove that x1 square into v2 square minus v3 square plus x2 square into v3 square minus v1 square plus x3 square, then v1 square minus v2 square is equal to 0. So how to deal this problem? So you know that for a simple harmonic motions we have v square is equal to mu into a square minus x square. So according to the given condition, v is equal to v1 when x is equal to x1, v is equal to v2 when x is equal to x2, v is equal to v3 when x is equal to x2. So use this condition in equation 1. So you will get v1 square is equal to mu a square minus x1 square. Similar way you will get this equation 3 and 4. So now in order to prove this result, just to see here nicely, here v2 square minus v3 square. So you take the difference accordingly. See, it is 3 minus 4. So because you are getting here v2 square minus v3 square, so you find out this expression. So 3 minus 4, if you do the subtraction, so what you will get? v2 square minus v3 square mu x3 square minus x1 square. Same way you find out this one, take the difference, 4 minus 2 you will get this, then 2 minus 2 you will get this. So now in order to get the required expression, what you have to do, you have to multiply this 5, 6 and 7 by x1 square, x2 square and x3 square, and after that you have to add. So if you do this operation after adding, it is you will get the required expression what you have to prove. So this way we can solve these problems. So hope it is understandable. So in next class we may solve some more problem, or we'll start with a new topic. Thank you.